Hi, I'm Dave Fricke from Lehigh Defense. Today we'd like to introduce you to a new line of ammunition we have for the 300 Whisper 300 Blackout. This is a subsonic round, 194 grains at 1,040 feet per second, fully AR compatible over a multitude of rifles and also magazines. The design goal of the ammunition was to provide outstanding terminal performance, complete reliability of feeding, and accuracy out to over 100 yards. If you look at the expanded bullets in front of you, these were fired at 1,040 feet per second in ballistic gelatin, 10% ballistic gelatin. The expansion rate is 1.2 inches at the maximum expansion point. This bullet is a redesign of our earlier 200 grain version. What we've done is thinned the nose out, changed some of the internal profiles to be able to provide a little bit better expansion and complete reliability of feeding in 30-round magazines, and it's full auto compliant. What we're going to demonstrate is once again the 194 grain Lehigh maximum expansion subsonic bullet. This is a Lancer L5 mag, 30 round mag, and I'm going to turn this over to Rich and let him have some fun.
Let's fire.
We're now going to evaluate various differences in terminal performance for subsonic design. What we have on the left is a 220 grain bullet. Next in the middle, a 208 grain bullet. And to the right is our 194 grain maximum expansion for the 300 Whisper 300 Blackout. We have a unique position here at Lehigh Defense where we're able to develop the bullet, design it in-house. We do all the manufacturing of the bullet in-house, and we also test the bullets for terminal performance, velocity, and accuracy. That can also be done in-house. So we're not using somebody else's bullet design to manufacture our ammunition. We're just going from the ground up with a solid piece of copper bar, machining on a CNC machine, developing it to its optimum performance, and then loading it in-house to those performance characteristics. Today we're going to show you how we test for a water test in-house, and then also move on to a gelatin test of these three different designs. The terminal performance of all our designs has to be proven in 10% ballistic gelatin. After that, we also try to get the design to work into water. This way, the average customer can go ahead and climb up on the roof if they want to, shoot down into a 55-gallon drum or trash can full of water, and duplicate the results that we get in ballistic gelatin. So we're going to demonstrate that now with our new 194 grain maximum expansion.
That's hard.
Okay, let's see what we got. We don't drink this water, by the way. There's no sense in picking them up. If you look at the terminal performance, this is 1,040 feet per second, 194 grain bullet shot into a water column. Perfect expansion. On subsonic bullet design, terminal performance is key. The goal is to dump all the energy as you can into the animal, into the intended target, not on the other side of the intended target. So what we're going to do for our test procedure, we have a block of 10% ordnance gelatin, 6 inches by 6 inches by 16 inches. Backed up by a backer so we can catch any bullets that pass through. The block's been calibrated to the FBI protocol, and we'll see how we do with 3 different tests. All right, let's look at what we have. The 208 grain bullets on the left made a complete pass-through through the block. The middle bullet down into the gel is the Lehigh bullets. We're right at 15.5 inches of penetration, perfect expansion. The bullet on the right is the 220 grain, once again passed through the block. A big important key in terminal performance in subsonic is you want to transfer the energy to the animal. You can see the other two bullets were not able to do that. The Lehigh bullet was able to do that and left nothing on the table.